Hi everyone, and welcome to this Keipert Labs video. We're going to be talking through the groups of the periodic table. Okay, so in the previous video, we talked about introducing you to get working your way around the periodic table. What do you see when you're there? And today we're going to look a little bit more specifically at the properties and some examples of the groups that we encounter in the periodic table. Okay, so just going to quickly kind of recap to show you this in the last video. Okay, so remember that when we're talking about the periodic table, that when we're looking at the columns that we see in the periodic table, that we refer to those as groups, and that when we're looking at the rows of the periodic table, which we've also numbered, we refer to them as periods. Okay, so groups and periods. So remember that vocabulary. You'll need to be really familiar with that sort of terminology. Okay, and we also showed you how we can also identify where to find metals, non-metals, and metalloids in our periodic table. Okay, but so now what I'm going to do, I'm going to move the periodic table out of the way and use the whiteboard underneath, and we're going to talk you through groups 1, 2, and then particularly groups 1, 2, 7, and 8, because they're really quite distinctive. They behave very similarly to each other. Okay, so let's use our space. Okay, so let's start with group 1. Okay, so group 1 is known as the alkali metals. Okay, so we're talking examples like sodium, lithium, and potassium here. Okay, so they're the kinds of examples that we're talking about. So that they're violently reactive. Okay, so if you're not sure what I mean or what that involves, feel free to have a look on YouTube for putting sodium in water. People, as typically on YouTube, they take things to the nth degree, so that's always fun to watch. So violently reactive, and that's with oxygen in the air, and that's with water as well. So that they may explode when they're present with oxygen, or they react so violently with water that they would explode as well. Okay, they are metals. Okay, so that they have the same sort of properties that all metals would do. That they tend to be silvery in colour. They're generally able to conduct electricity and heat. Okay, but these ones are very, very soft and brittle. Okay, so they're not hard and it's not like an iron nail or a piece of aluminium. That they're really kind of soft, solid. And they, really soft. You can cut them with a knife. Okay, so they're different to what you would expect. Okay, let's have a look now at group 2. Okay, so group 2 are known as the alkaline earth metals. Okay, so here we're talking about calcium, magnesium, we might be talking about barium as some examples. Okay, so that they also now I didn't the name itself doesn't make particular sense as far as that other metals come from the earth as well. This term alkaline, or alkali as we saw with group 1, relates to, it's like in terms of acids, how acidic something is. Alkaline is the opposite of acidic, and so because when we put these metals in water, that they make a solution that's the opposite of acidic, it's alkaline. Okay, so that they tend to still be very reactive with oxygen and with water, but less than group 1. Okay, so they tend to be safer to be able to do with. You can take a piece of magnesium and put it in water, and it's not going to blow up in your face. But there will be a reaction more so than with other less reactive metals like copper or gold. Okay, and magnesium, if you've ever done it before, when you burnt it, like in a Bunsen flame, and it gives a bright white flame. Okay, so that they still tend to be soft. So soft and brittle metals. Okay, so again, different to your typical, like an iron nail. That's something that you might normally think of when you think of the word metal. Okay, so that's group 1 and group 2. Okay, so looking at our periodic table, remember that we said that section in the middle was a little bit like Wild West. It's all metals, but chemically there's a little bit more variety in what our different groups do. And then what we're going to do is we're going to skip groups 3, 4, and 5 and 6. Because what we get is that you notice that if I put the periodic table back under the camera, whoops, you notice that groups 3 to 6 here have some that are over each side of the border. Okay, so it's harder to actually say a more conclusive pattern in terms of, right, well, what elements in this group are like this. So say group 4, you've got 2 that are above the line and then 4 that are below. One of which is only very recently been discovered, so we don't know very much about it. But so, some are metals, some aren't. Carbon and lead are very different to each other, even though they're in the same group. So it's not really very clear for us to talk about. Whereas once we start to get to group 7 and group 8, we see more consistency. So we'll talk about those. Okay, but if you're keen to know any more about the other groups, please feel free. Okay, they do have names and so on. Okay, so group 7 are known as the halogens or halogens. Okay, so we're thinking about fluorine, chlorine, bromine, iodine as our typical ones. Now, if you have a look at the periodic table, there's also an element right down the bottom called it's called astartine, AT. Now, the reason I haven't really listed that is that astartine is so rare in the world, it's so rare in the crust of the Earth that we actually haven't ever collected enough to actually test it and know about it. It's so rare. So it's not really worth talking about in this same kind of thing, because we don't know enough. Okay, so what we're thinking here when we're looking at halogens, that we're talking about non-metals. Okay, so then we're thinking their behaviour is very different. So we say mix of solid, which is iodine, liquid, which is Br, and gas, which is our Cl and our F. Okay, so what we see, so some of them are solid, some of them are liquid, some of them are gas. And so, so that's quite different, whereas all the metals and things we've been looking at have been much more consistent. Okay, but they are still very reactive. Fluorine especially is probably the most reactive element in the periodic table. It will violently react with just about anything you could possibly mix it with, and it's very, very dangerous. Especially when you put it in water and it becomes an acid, hydrofluoric acid, if you've ever seen Breaking Bad. Okay, so very reactive. We've got non-metals. They're a mixture of solid, liquid, and gas, which makes them very different. And they're also highly toxic. Okay, so chlorine gas was one of the first chemical weapons used in World War I, and very, very nasty stuff, as is everything else there. Iodine, however, is actually toxic to a degree, but it also kills bacteria. So we use it in things like betadine to kill bacteria, and sterilize things for surgery. That it actually, we notice that it has that function. All right, the last thing that we're going to go through is we're going to talk about group 8. Okay, so talking about group 8 is we're talking about what's called the noble gases, or sometimes known as the inert gases. But we will tend to use this term of noble gases, okay, when we're referring to these ones. So we're thinking about helium, neon, argon, etc. Okay, they are non-metals. Okay, they are gases at room temperature, and you have to cool them to incredibly low temperatures before they become liquid. I don't think they've ever been isolated as solids because you have to get them so cold. Okay, now the thing that's really interesting about the noble gases compared with group 7 is that they are almost completely unreactive. Now, I say almost completely because in chemistry, as in often in areas of science, is that if under the right conditions, sometimes we can force things to happen that naturally wouldn't. So you can never say never, but naturally they are very unreactive, and that's where the term inert comes from, which means unreactive. Okay, and so yeah, so they're almost completely unreactive. They're gases. They also give off coloured light with electricity. So we talk about neon lights, for example, that if we put a sample of neon in a glass tube and then attach an electric current, that it will glow a red colour. And the other noble gases have distinctive colours as well. Now, other elements do this as well, but the noble gases are particularly known for the colours that they make. And we use them in all sorts of lighting and things like that for that reason. Alright, so we've talked about group 1, 2, group 7 and group 8, giving you a little bit of extra information about elements in these groups. That wraps it up. Thanks very much for watching. Bye for now.